Hello friends, my name is Tushar and today I'm going to discuss the question maximum size rectangle of all ones in a two-dimensional matrix. So you are given a two-dimensional matrix of zeros and ones, and you have to find the maximum size rectangle of all ones in this matrix. For example, this is a rectangle of size 3 or this is a rectangle of size 6. So you have to find the rectangle which has the maximum size of all ones. In my another video, I discussed how to find the maximum square of all ones in a two-dimensional matrix, but this question is different from that question. So here we will use dynamic programming and maximum area rectangle in a histogram to solve this problem. In another video, I already discussed how to find a maximum area rectangle in a histogram. But let's quickly summarize it. If you are given an array 3, 2, 3, 2, this is the histogram you get where height is 3 and width is constant 1. The maximum area rectangle here will be of area 8, and this is that rectangle. So we will use this algorithm and dynamic programming to solve this question. This algorithm runs in O of n time. So basically we can find the maximum area rectangle in O of n time. So let's solve this question here. Alright, let's have another array of same size as the total number of columns in two-dimensional matrix. So my array length is 6, going from 0 to 5 because I have 6 columns in my two-dimensional matrix. First thing we do is we copy 0th row as it is there. So this becomes 1, 0, 0, 1, 1, 1. Then I'll find a maximum area rectangle using this array. So let's create a histogram for this. So this looks something like 1, then 2 zeros, then 1, 1, 1. So maximum area rectangle in this histogram is this, and its area is 3, which is our max area is 0. So this area is greater than max area, so max area becomes 3. This can be found in O of n time. Next, let's bring row 1. So if this value is 1, we go and add this value here, so this becomes 2. If this value is 0, so in the corresponding column here we make it 0, so this is already 0. If this is 1, we go to 2 and may add value here, so this becomes 1. This is 1, so this becomes 2. This is 0, so this becomes 0. And this is 1, so this becomes 2. Let's create another histogram based on this array. 2, 0, 1, 2, 0, and 2. So the maximum area here we can get is of 2, either this one, this one, this one, or this one. And the max area found till now is 3, so we will not change our max area. Let's bring row number 2. So if this value is 0, let's make this guy 0. If this value is 1, we add it here, so this becomes 1. If this value is 1, we add it here, so this becomes 2. If this value is 1, we add it here, so this becomes 3. Since this value is 1, we add it here, so this becomes 1. And this value is 1, so we add it here, so this becomes 3. Let's create a histogram for this array. So this is 0, then we have 1, then we have 2, then we have 3, then we have 1, and then we have 3. 1, 2, 3, 1, 3. So the maximum area here is of area 5, and that area is this area. So since this max area 5 is greater than the max area found till now, so our max area becomes 5. Alright, let's bring the last row into that array. So since this value is 0, this becomes 0. This value is 0, so this becomes 0. This value is 1, so this becomes 3. This value is 1, so this becomes 4. This value is 1, so this becomes 2. And this value is 1, so this becomes 4. Let's create a histogram based on this array. So histogram will look something like this: 0, 0, and then 3, and then 4, and then 2, and then 4. The maximum area here will be this one, and its area will be 8, and that area is greater than the max area found till now. So our max area becomes 8. So this is it. The max area rectangle, max size rectangle in this two-dimensional matrix will be of size 8, and that rectangle is this one. Let's analyze the time and the space complexity. The space complexity is pretty clear. It's same as the total number of columns. So our space complexity is O of columns. If the number of columns is way more than the number of rows, then you can sweep in this vertical fashion instead of sweeping in this horizontal fashion. And in that case, our space complexity can become O of rows. The time complexity is for every row, we are copying this information here. So that takes O of columns time. And then we are finding a max histogram. So that also takes O of columns time. So our total time complexity is O of rows into columns. The link to the code is in the description section of the video. I would ask my viewers to like this video, share it, and subscribe to my YouTube channel, youtube.com user Tushar2525, and visit my GitHub link, github.com mission piece interview wiki. Thanks for watching this video.